This is Math 261, Section 12.5 on arc length, and this is Part 2, Example 2. Sketch the space curve. So we'll identify the graph of this vector-valued function, r of t equals negative ti plus 2tj plus 4tk over the interval t equals 0 to t equals 1. So our first step will be to identify the graph of that, and then we'll find the length of that line segment. It will be a line segment in 3 dimensions. So that's what this example is all about. Finding the length of a line segment in 3D. All right, first of all, identifying the graph. Let's plug in t equals 0 and t equals 1 so we can see where the line segment starts when t equals 0 and where it ends when t equals 1, and see if we can identify the graph from that. So r of 0 would be negative 0 times I plus 2 times 0 times j plus 4 times 0 times k, which would be 0, 0, 0. Okay, so this line segment starts at the origin, and just take a look at all these graphs. They all have one of the endpoints being the origin, so that's nice, but not particularly useful. Let's see what we can glean if we look at r of 1. All right, so that would be negative 1 times times I, excuse me. T is 1, plus 2 times 1 times j, plus 4 times 1 times k. Or I'm going to do these in component form. Switching back and forth between IJK form and component form. And that's not necessary, of course. It's just a little easier, I think, for most people to digest, like the point plotting aspect of the vector-valued functions when you do component form with the angle brackets, because that essentially is a point compared to IJK form. I mean, it's just a little thing, so it doesn't really matter, but that's why I've gone to component form for these. Okay, so like basically now we're looking for the point negative 1, 2, 4 as the end point of our interval that's being traced out as the parameter t goes from 0 to 1. All right, so if we look at the first graph here, what do we have? Negative 1 would be on the x-axis. You gotta really pay attention to what axis is what. It would be down here. And then 4 in the y direction, which would be to about here in the y direction. Excuse me, I'm sorry. Negative 4. Negative 1 is x. 2 is y. And positive 4 is z. So, it's definitely not this graph, but here's a 2 in the y direction, and then z is positive 4. So on the z-axis, 4 units up is that. You're going to got to translate that to above this point right here, which is kind of hard to do, but I'll try to do it. A line segment about that long. So we're looking for a point about there. This one definitely doesn't cut it. Second one looks promising. Second one looks like about what we just thought through and ended up drawing with this example here. I'll kind of get rid of some of this scratch work here. See, we're starting at the origin. We're going up to this negative 1, 2, 4. So I do believe it's the second one, and yeah, these two don't look like it at all. Okay, so that's the graph. And now our job is we're going to use the formula to figure out the length of this line segment that's being traced out when t. So imagine a point when t equals 0. It's at this location that's moving through space. Neat. When t equals 1, it's at that location. And by using the formula for S, we figure out how long that line segment is. Kind of neat. Alright, so to use this formula, the first thing we need to do is the derivative r prime of t, which would be negative 1I, so negative I, plus, I have 2j there, but I think it's 2tj. And so the derivative of 2t is 2j, plus the derivative of 4t is 4, so plus 4k. And then we need the length, the magnitude of r prime of t, which will be big square root negative 1 squared plus 2 squared plus 4 squared. So that'll be 1 plus 4 plus 16. And then for the arc length, that's the integral s equals the integral from a to b. And a and b in this problem are 0 and 1. So the integral from 0 to 1 of what we just found, which is the square root of 21 dt. Square root of 21 is a constant, so the integral of square root of 21 is square root of 21 times t, evaluated from 0 to 1. Square root of 21 times 1 minus the square root of 21 times 0. So this is the square root of 21.